Hello friends, I am Narayan Pawars. We will discussing about aliphatic amines as per the PCI syllabus. The definition aliphatic amines. The definition of aliphatic amines. Aliphatic amines are derivatives of ammonia in which one or more hydrogen atom have been replaced by alkyl groups. It means amines are derivatives of ammonia. Ammonia, the structural formula NH3, in that nitrogen contains two lone pair of electrons, and any of the hydrogen are replaced by alkyl groups are called as amines. Means amines are derivatives of ammonia in which one or more hydrogen, this one or this one hydrogen have been replaced by alkyl groups. If any one of the hydrogen are replaced by alkyl groups is called as aliphatic amines. If hydrogen are replaced by aromatic rings, is called as aromatic amines. Then the nitrogen containing a lone pair of electrons, and the valency of nitrogen is 3. That's why 3 hydrogen atoms are bonded with a nitrogen and 1 lone pair of electrons are present in nitrogen. This is the structure of ammonia. This is the structure of amines, generally methyl amines, primary amines. It means the definition said about the derivatives. Amines are derivatives of ammonia in which the hydrogen atom have been replaced. This hydrogen are replaced by alkyl groups. These one alkyl groups. This is the amine. This is called as amine. Generally aliphatic amines, because of the alkyl groups are replaced by this one hydrogen, any one of the hydrogen from the ammonia is called as amines. The classification of amines, there are 3 types of amines. Generally amines are classified into 3 types on the basis of replacement of hydrogen. The hydrogens containing ammonia, 3 hydrogen are bonded with nitrogen, or ammonia containing 3 hydrogen. It means if one hydrogen replaced by any of the alkyl groups, it is called as a primary amines. If 2 hydrogen replaced by 2 alkyl groups, is called as a secondary amines. If all of 3 hydrogen are replaced by alkyl groups or any cycloalkyl group, or is called as a tertiary amines. Amines are classified into 3 types. First, primary amines. In that primary amines definition, a primary amine has only one alkyl groups directly attached to the nitrogen. It means the alkyl group directly attached to the nitrogen atoms. It means the primary amines means the replacement of only one hydrogen. Replacement of only one hydrogen by alkyl groups or any of the groups is called as a primary amines. In that the primary amines, the ammonia of the one hydrogen are replaced by the alkyl groups. The hydrogen of ammonia are replaced by the alkyl. It's called as a primary amines. Primary amines means the replacement of one hydrogen of the ammonia. by the alkyl groups is called as a primary amines. A primary amines has only one alkyl group directly attached to the nitrogen atoms. This means the remaining two hydrogen are directly attached to the nitrogen. It is a primary amines. Everyone get it clear? Amines are the derivatives of ammonia. This is the derivatives of ammonia. The one or more hydrogen have been replaced by the alkyl groups. It's called as the amines, the primary amines, in that the only one hydrogen are replaced. Then next, secondary amines. In that, secondary amines has two alkyl groups directly attached to the nitrogen. Here two alkyl groups are attached to the nitrogen. It means two hydrogen of ammonia are replaced by two alkyl groups, and the two alkyl groups are replaced by two hydrogen. That is nothing but a secondary amines. Secondary amines has two alkyl groups directly attached to the nitrogen. The alkyl group directly attached to the nitrogen atoms. That's why this is the secondary amines. The name of these amines is dimethyl, not a ethyl, dimethyl amine, because of the two methyl group are attached to the nitrogen. Di means two. Methyl group are attached to the amines, and one hydrogen are remain in the directly attached to the nitrogen. In case of secondary amines, the two hydrogen are replaced by alkyl groups and one hydrogen are remains exist. The next, tertiary amines. Definition of tertiary amines: a tertiary amine has three alkyl groups directly attached to the nitrogen. It means three alkyl groups are attached to the nitrogen atom. Here the H is capital. This is H is CH3. It means the example of tertiary amines is trimethyl amines. Trimethyl amines. It means all of the hydrogen of ammonia are replaced by alkyl groups. Generally ammonia containing three hydrogens. Three hydrogen replaced by three alkyl groups or three groups. This is the tertiary amines. Tertiary amines has three alkyl group directly attached to the nitrogen. So everyone get it clear about the classification of amines. There are three types: primary amines, secondary amine and tertiary amine. So next we will move towards a basicity of amines. Generally amines are basic in nature. Amines are basic in nature. Why amines are basic in nature? Because they possess an unshared pair of electrons or lone pair of electrons on nitrogen atoms. Amines are basic in nature because they possess an unshared pair of electrons or also lone pair of electrons on a nitrogen atom. That's why amines are basic in nature. Here the amines. This is a amine R, single bond NH2. R amines. It contains a lone pair of electrons. That's why it is a basic in nature. Next, this lone pair of electron is available for the formation of a new bond. This lone pair of electron are available for the formation of a new bond with a proton or a Lewis acid. With proton or Lewis acids means amines are basic in nature. Lewis acid. Lewis acids means the Lewis acid are electron pair acceptor. In that the hydrochloric acid, the hydrogen atoms are accept this lone pair of electrons. Means Lewis acid it's accept a lone pair of electrons, means hydrogen accept a lone pair of electrons. And Lewis base means electron pair donor, means amines. These amines are donator this lone pair of electron to the hydrogens. Means on the nitrogen atoms there are two lone pair of electron are present, it's donate to a hydrogen. Means as per the Lewis concept, the amines are Lewis base because of they containing a lone pair of electron. Means Lewis base are donate a lone pair of electron or pair of electron. It means the amines are, that's why amines are basic in nature, because it's contain a unshare pair of electron or lone pair of electron on the nitrogen atoms. Everyone clear? And this lone pair of electrons are form a new bond with a Lewis acid. Lewis acid are the proton or it's accept a lone pair of electrons. Then that's everyone clear about the nature of amines. Amines are basic in nature. The reason of behind the basic nature of amines, because of its contain a lone pair of electron on the nitrogen atoms. And why this lone pair of electrons present of this lone pair of electrons, its amines act as a basic in nature, because as per the Lewis theory, basic amines or basic base, the definition of as per the Arrhenius, base are donate a lone pair of electron to the Lewis acid. It means amines are Lewis base, or amines are generally basic in nature. And then next, the amines react with acids. These amines react with acid to form a salt. This is a salt, ammonium. Generally the salt called as a ammonium salt. Means the hydrogen are accept lone pair of electron and form a new bond with a NH2 N of the lone pair. The formation of R single bond NH3. The vacancy of nitrogen is 3, but it's having a lone pair of electrons. These lone pair of electrons are generally form a new bond with a hydrogen. Means here the one lone pair of electrons are deficient, that's why these amines are deficient in nature, that's why here positive charge are given. And the chlorine have a more electronegative atoms. It is tendency to abstract the electron pair or bond containing electron pair. This is the HCl containing sigma bond. The bond are generally abstracted towards the chlorine, because chlorine have a electronegative atoms. Electronegative atoms are tendency to abstract pair of electron towards its. Means the chlorine having a increase, or it's having a more electrons, that's why it's given a negative charge. And amines, nitrogen having a deficient electron, that's why it's given as a positive charge. And the formation of salt means it is a chloride are electrolytes, it's formed. This is the alkyl ammonium chloride, the salt formation of alkyl ammonium chloride. The amine react with acid to form a, generally acid containing hydrochloric acid, here we taking example as a hydrochloric acid, to form a alkyl ammonium chloride. Why this is onium? Because of here the ionization or positive charge, that's why ammonium. Everyone clear? Basicity of amines. Amines are basic in nature. Then next, stronger bases. Example of stronger bases are NaOH, sodium hydroxide and potassium hydroxide. Why these sodium hydroxide and potassium hydroxides are strong base? As per the definition of strong base, the strong bases are completely ionized, means sodium hydroxide and potassium hydroxide are completely ionized in aqueous solution. When it dissolve or when it dissolve in a aqueous, it's completely ionized. It is completely ionized, means it's produce a N positive charge and OH minus charge, means completely ionization of sodium hydroxide in a aqueous solution. Here potassium having a positive charge, hydroxide ion having a negative charge. So clear, strong bases because it is completely ionized in a aqueous solution. That's why the sodium hydroxide and potassium hydroxides are strong bases. Next, amines are weak bases. The nature of amines are, we know amines are basic in nature, but it is a weak basic in nature. The reason behind the weak base of amines is they are only partially ionized in aqueous solution, means amines are partially soluble or ionized, not a soluble, it's ionized, partially ionized in a aqueous solution. That's why amines are weak bases. Why amines are not a strong basis? Because they are not completely ionized in a aqueous solution. Amines are only partially ionized in aqueous solution, and the ionized and equilibrium exists between the ionized and unionized form. This is the amines are partially ionization. Here ionization is partially, not a completely. These amines are not completely ionized, it is a partially ionized in the positive and negative. Hydroxide ion and alkyl ammonium ion. This is the alkyl ammonium ion, this one is a hydroxide ion, means ionization of amines. Means amines when in a aqueous solution means a water, aqueous means a water. Generally in a aqueous solution, amines in a aqueous solution, the partial ionization means amines not a completely ionized, means alkyl ammonium, this ion is alkyl ammonium, this one is a hydroxide ion. It is partial, not amines are not completely ionized in a aqueous solution, and it reaches the equilibrium, not a completely, means it reaches the equilibrium between the ionized state. This is ionized, this is ionized, this one is a unionized. These are equilibrium. That's why amines are weak bases. Everyone clear about the what is mean by strong bases and what is mean by weak bases? Weak bases are partially ionized, strong bases are completely ionized in a aqueous solution. Next, effect of substituent on basicity of amines. Effect of substituent on basicity of amines. Aliphatic amines are stronger bases than ammonia. Aliphatic amines. Which amines? Aliphatic amine are stronger bases than ammonia. Because the reason of the aliphatic amine are strong bases than ammonia, because the aliphatic amines having the alkyl groups. Alkyl groups are electron releasing. This is because the alkyl groups are electron releasing. means aliphatic amines containing a alkyl groups. Alkyl groups are electron releasing in nature. Here the ammonia in that ammonia are less basic than the aliphatic amines. Aliphatic amines are more stronger basic than the ammonia. The reason because it's containing aliphatic amine containing a alkyl groups, because alkyl group have tendency to release the electron towards the nitrogen atoms. Means the increase the electron density around the nitrogen atoms. Means alkyl groups are releases the electron towards the nitrogen. It means the density of nitrogen is increases. The density of nitrogen is increases, thereby the increase the availability of the lone pair of electrons. Means here the nitrogen containing lone pair of electrons are more available. In case of more available than the ammonia, because here hydrogen have less electron releasing than the alkyl groups. That's why aliphatic amines are more or strong base than the ammonia, because it releases a electron. The density of nitrogen is increases. The density of nitrogen is increases, means lone pair of electrons are available is more is the lone pair of electron available. It is easily, or the properties of lone pair of electrons donate of this amine is more, as per the definition of Lewis acid. Lewis base are the lone pair of electron donors. More is the electron pair, it's easy or increases their tendency to donate an electron pair. It increases the tendency or increases the tendency of electron pair donors. It increases the basicity of amines. It means the increases the electron density around the nitrogen, thereby increases the availability of lone pair of electrons. That's why aliphatic amines are stronger bases than the ammonia. The greater the number of electron releasing alkyl groups, the greater the availability of nitrogen lone pair and stronger the base. It means the greater number of electron releasing alkyl groups. In that ammonia having no one alkyl group are present, but methyl amines containing one alkyl group. Alkyl groups are electron releasing. In case of dimethyl amines, in that dimethyl amines two alkyl groups are present on the amines. In case of trimethyl amines, there are three alkyl group are present. It means the greater the availability of nitrogen's lone pair and stronger the bases. Means the alkyl groups have tendency to release the electron pair electrons here. That's why the nitrogen containing lone pair of electron is more available. It means here in case of trimethyl amines, there is more electrons are available than the dimethyl amines. Dimethyl amines having more electron available than methyl amines. Methyl amines having a more electron than the ammonia. This is structure of ammonia. NH3 means more electron pair available, means their basicity is more, or the group or amines are more basics. The pKb, not a pKb means base dissociation constant. The value of base dissociation constant. The ammonia base dissociation constant value is 4.784, methylamine 3.36, dimethylamine 3.27, trimethylamine 4.19. Means if the more is the pKa value, less the basic in nature of compounds. It means the dimethylamines containing pKa value 3.27 means it is a more basic. Dimethylamines are more basic than a methylamine. Methylamines are more basic than a ammonia. Means in that 3 of group, the strong base is dimethylamine. Dimethylamine are more basic than methylamine. Then methylamine is more basic than ammonia. Because of its dimethylamine containing a 2 alkyl group, their lone pair of electron available is more. Then next, here the pKb value of trimethylamine is 4.19, means it is a less basic. Why it is less basic? We consider the trimethylamines are less basic than dimethylamine and trimethylamines. Because although in trimethylamine the electron density is further increases, means electron density of nitrogen or here present of lone pair of electron, it's more available than a dimethylamines because of 3 alkyl groups, electron releasing group are present in the trimethylamines. But why it is less basic than dimethylamine and methylamines? The reason, their steric crowding or steric effect of 3-methyl groups makes. Here 3-methyl groups are make a steric effect, steric inversion effect. The steric crowding of 3-methyl groups makes the approach and bonding by the proton relatively difficult. Means it produces a 3-methyl group produces a steric effect. Steric effects means generally electrostatic effects, steric inversion effects. It produces some steric or some restriction to attach a hydrogen bond. Means here the electron are there but the path is blocked. Means here this lone pair of electron is more available. Why this is more available? Because of the 3-methyl groups are attached to the nitrogen. The methyl groups are electron releasing. Here lone pair of electron is more available, but the hydrogen or Lewis acid having the acceptor lone pair of electron or Lewis base are donator lone pair. It is the path of this attacking of the hydrogen is blocked. It is blocked or some restricted because of it produces a steric effect. Trimethylamines are produces a steric effects. That's why dimethylamines and methylamines are more basic. Dimethylamine and methylamine are more basic than a trimethylamines. Okay. Then next one is the factor affecting or the types of substituent on effect of the aliphatic amine. Generally electron releasing groups. Electron releasing groups are alkyl groups. Increases the basicity of amines. Electron releasing group are increases the basicity of amines, means it increases the density of nitrogen or more available of the nitrogen containing lone pair of electron are more available. means if the nitrogen attached with the alkyl group or electron releasing group. Electron releasing groups are alkyl group. If alkyl groups are attached to the nitrogen, it's more available the lone pair of electrons, and then increases the basicity of amines. Means electron releasing groups increases the basicity of amine. Example, the electron releasing groups are alkyl groups. Next, electron withdrawing groups decreases the basicity of amines. The example is chlorine, bromine, fluorine, hydroxide. Means electron withdrawing groups are decreases the basicity, means it's withdraw electrons from nitrogen towards the outer side. Means here the hydroxide ion are present, it's abstract electrons, means here the bond is their electron is abstracted towards, that's right. Means here nitrogen density is less or reduces, or the lone pair of electron is less available, that's why it decreases the basicity of amines, because this, if the lone pair of more available, it's react with the or form new bond with the hydrogen Lewis acid, but it is less available, means it is a less basic in nature. Means electron withdrawing groups are decreases the basicity of amines. That the example of these electron withdrawing groups are chlorine, bromine, fluorine or hydroxide ion, and so on, etc, etc. Then it means any factors which reduces the availability of lone pair of electron on nitrogen. Any factor which reduces the availability of lone pair of electron on nitrogen, it means reduces the basicity of amines. It increases the availability of lone pair of electron, it increases the basicity of amines. If the reduces the availability of lone pair of electrons on nitrogen, reduces the basicity of amines. Then next, lone pair more available, it means if the lone pair are more available on nitrogen, the amines are more basic. If the lone pair less available on nitrogen atoms, amines are less basic in nature. So guys, I think everyone understood. Thank you so much. Thank you.